All right, good morning, everybody. Start joining the class. Is live now.
Who is there? Who is there? Who is there?
Leave that place. Okay, we are live now. You can start joining the class. Okay, so I don't know if Zikora is on the chat already, on the group, on the live already. So you can start recording your presence, write your attendance, your name, your reg number, and your department. Your name, your reg number, and your department. Um, then Zeke and Evans, you can go ahead and take the attendance. I'm just going to give 5 minutes for people to join, and then we'll start this class. There is no time. Yeah, good morning, Joshua. Good morning, Perpetua. Good morning, Jessica. Good morning, Noni. Good morning, Mary. Good morning, Vivian, Diamond, Mary, Confidence. Good morning, all of you. Okay, so 2 minutes more. 2 minutes more to join the class. And unlike before, like I said, anybody that is not in this class, after 30 minutes we started. Zikora and the Evans, don't record the attendance. It does not make sense. Meanwhile, as you're joining, give a thumbs up to the video, like the video as you're joining, so that yeah, Joy, how are you? You're welcome. You're welcome. Okay. Okay. Um Okay. Not the love emoji. Leave the chat, as in touch the cross on the chat and then go to the like button there. The love emoji, we use it when we are learning. When you just see the like and then click it. Okay, I think this is exactly 8:05, so we can start the class. All right. So I hope we are very fine. Okay, yeah, Rita is here. So Rita says made a request that we should be using the yellow marker so that it will be clearer. All right, so I remember that. Okay, so let's go on. So in the last class we started talking about the concept of dot product. So we're able to define dot product. There are a number of things we defined in that class. We touched unit vectors in the direction of a vector. We touched a number of things. Okay, so now when it comes to dot product, it is actually one of the applications. When it comes to orthogonal vectors, it's actually one of the applications of dot product. Zeke, if you are here, you can kindly write on the WhatsApp that I said the attendance ends by 8:30, please, so that somebody will not say I did not inform him or her. Okay, all right. So now today, we are going to be defining dot products. So after defining dot products, we will now look at some examples involving dot products. And then after that, we will now progress to direction angles and direction cosines. Okay, so did I say dot product? Orthogonal vectors. Okay, so when are two vectors said to be orthogonal? So definition. Okay, so let U and V be vectors. Okay, so if we have two vectors U and V, all right, so orthogonal is actually another word for perpendicular. Okay, so two things are orthogonal, or two vectors are orthogonal, implies that they are perpendicular. Okay, so what that means is that V and U are orthogonal if the angle between them is 90 degrees. Okay, so in other words, so now that brings to mind what we now want to particularly study now. So two vectors are orthogonal now. So what does that imply? So it now implies that the dot product of the two vectors is going to be equal to 0. Okay, so this is the most important deduction that you will have from dot products of vectors. Okay, and then in terms of orthogonality, so that means you can actually define the orthogonality of two vectors by saying that it means that that their dot product is equal to 0. So we can say that let U and V be two vectors. So be vectors. I forgot to put that. Let U and V be vectors. So both of them are orthogonal if their dot product is equal to 0. Okay, and so we are going to see some examples involving this concept. For instance, if we come into exam and then we ask you, like if you remember when we did dot product, there was a particular example I gave you and we got the dot product to be 0. Let me try to recall. I think we gave you as 4i plus 2j. If you will remember, maybe if you check your notes, you will find, I think it is this one, and then we gave V as I plus J, and then plus 3K. Evans, you are welcome. Okay, plus 3K. So I think it was this. Let's check it quickly. So if we do U dot V, so what we are saying is that you have 4 times 1, and then plus 2 into 1, and then minus 2 into 3. Yes, is this one. Okay, so here you are going to get, this is 4 plus 2, which is 6, and minus 6, and that is equal to 0. So that means, so this simply means that U is orthogonal to V. That means U is perpendicular to vector V. Okay, so that's one example. And then we are now going to go further into beginning to apply this, because like I will always say, the important thing is not, we are not going to just ask you to check if these two vectors are orthogonal. We would like to also bring in some application question. For instance, look at this. Like this example here, they are just asking us to check. Okay, so let me draw the line here. Okay, so example 2. Here they said we should show that the vectors minus 5i plus the root of 3j and the root of 27i plus 15j are orthogonal. Okay, so when it comes to orthogonal vectors, the two vectors must also have the same dimension. The dimension does not matter. It can be 2, 3, 4, 5, 6. But the only thing is that for any two vectors to be orthogonal, two of them must have the same dimension. Okay, so Rita, you'll be permitting me to be changing pen small. Okay, you should check if green is okay. Alright, so for instance now, how do we show that these two vectors are orthogonal? All we need to do is to take their dot product and then confirm that their dot product is 0. Okay, so I'm putting it in bracket form now. So this is bracket of minus 5 root 3 dot root 27 comma 15. Okay, so we will try to see, will this dot product be 0? So if it is 0, then they are orthogonal. If it is not 0, then they are not. Alright, so let's go. Minus 5 times root 17. That's going to give us minus 5 root, did I say 17? 27. Minus 5 root 27. Then plus root 3 times 15. Yeah, good morning, Helen. You came in a little bit late today. So that's going to give us 15 root 3. Okay. So we will now try to simplify this to check if it is going to be 0 really. Alright, so can we reduce root 27? Yes, we can simplify it to, this will give us 9 times 3. Okay, and then we have plus 15 root 3. So this is going to be, of course, the root of 9 is 3. So when that 3 comes out of square roots, it will multiply this minus 5, and that's going to give us minus 15 root 3. Okay, so plus 15 root 3. Alright, and clearly you can see that this is equal to 0. Therefore, the first vector here is orthogonal to the second vector. Okay, if that made sense, you can show that you understood what we did there. So what it means is that we can actually ask you to confirm if some vectors are orthogonal or not. Okay, so this is one way of doing it. Just check that their dot product is equal to 0. Now, apart from that, so we can also begin to give you other kinds of questions to solve, and in that you will need to use the information of orthogonality of vectors. Okay, so I think this was example 2. So let's look at another example. Assume that you have example 3. Okay, so now this example 3, meanwhile, I hope the network is stable. Please confirm for me. Is it shaking? Let me check. No, it's not. Okay, it's excellent now. Okay, I'm seeing thumbs up. Okay, all right. Okay, so because I'm seeing some people fluctuating. Okay, so let's go on. All right, so now example 3. Yes, it's stable. All right, Joy, thank you. Okay, so let's look at this question here. It says find the value of k so that the vectors minus 6k and 2 and k comma k squared and k will be orthogonal. Okay, so remember, like I said, we can use the word orthogonal or we can use perpendicular. Okay, so both of them mean the same thing. So here they are asking us for what value of k will these two vectors here be orthogonal. For what value of k will these two vectors? So we can start hiding some variables and then ask you to get the values for which the two vectors will be orthogonal. But I think I want us to see the next example before this one. But let's go on. We can go on and do it. Okay, so please always confirm for any of the markers I'm using. If blue is okay, you can confirm, or I should not. All right, so what does that mean? For these two vectors to be orthogonal, what it means is that their dot product must be equal to 0. Okay, so that means minus 6k and 2 times k squared, k and k should be equal to 0. So why did I do that? By definition, two vectors are orthogonal if their dot product is 0. And when their dot product is 0, immediately I write this. So my job now is to find the value of k that will make this to be true. Okay, so and what do? I will now open the bracket. So minus 6 will multiply k and will give me minus 6k, and then k will multiply k squared to give me k cubed, and then 2 will multiply 2 will multiply k to give me 2k. All right, and this is equal to 0. Okay, so now I am now going to solve for k. So thank you. Okay, so what is that going to give me? So I'll first of all write k cubed, then minus 6k plus 2k will be equal to minus 4k. All right, and that will be equal to 0. So my job now is to find the value of k that will give us this. Okay, Eyong is saying, sir, please, why did we multiply minus 5 root 27 plus this instead of minus 5 root 3 plus this? I'm a bit confused there. Okay, you are really a bit confused because what you wrote is not what we did. Okay, see what we have here. We are asked to show that, come back here everybody, that minus 5 comma root 3 is orthogonal to this. So, and we now said, we asked ourselves, what is the meaning of what does it mean for two vectors to be orthogonal? So for two vectors to be orthogonal, their dot product should be 0. So since the question says that we should show that the two vectors are orthogonal, then all we need to do is to multiply the two of them, take their dot product, and confirm that it is equal to 0. Okay, so and that's what we did here. So we now, for the dot product, minus 5 multiplied 27. You know we do it component wise. The first component will multiply the first component, the second component will multiply the second, and the two of them will add. So minus 5 times root 27 gave us minus 5 root 27, and root 3 times 15 gave us 15 root 3. So all we did here was surd simplification. Your 101 mass 101. So we just simplified. Alright? So here now, how did we get that? We showed that, let me still remove this again. Okay, so we showed that root 27 can be written as root 9 times root 3. Okay, so why did we do that? Because by surd rule, if you multiply these two, you will still get back root 27. And so we had to break it down like this so that we will be able to get the same root 3. And you know that root 3 can only add to root 3. We usually say that only similar sorts can add. Okay, so that's why we needed to break it down to root 3 and root 3. Alright, so we bring down this one. So what we were doing there is simplification and addition, no longer multiplication. Okay, so here, this is the only place we multiplied, because by the time you take the root of 9, it will give you 3. And this root 9 is multiplying this minus 5. And so that root 9, which is 3 times minus 5, will give us minus 15. And so you will multiply it with this root 3 to now give you minus 15 root 3. So when you now add it to this one, of course, minus 15 plus 15 will be 0. So that's how we got 0 here. Eyong, if that is much better now, you can say that in the comment section. Okay, so back to where we were. So what we are currently dealing with is how do we get the value of k if these two are perpendicular to each other. So the question has already said that the two of them are perpendicular. So that means we have confirmed that their dot product must be 0. So that's why I wrote this first equation here. Because the question says that what will be the value of k that will make the two of them perpendicular. So we are assuming that the two are perpendicular and we are now looking for k. So, and that's why we have the first line. So then we will now open the bracket by taking that dot product, and the dot product first here will multiply the first, which is minus 6k. The second will multiply the second, which is k cubed. The third will multiply the third, which is 2k, and that is equal to 0. Okay, all right, Sylvia, that's okay. You came in a little bit late. Frances, you too. Okay, Eyong, I'm still waiting for your response. Marvelous. Is it better now? Okay, so all right, so now we added the k. We collected like terms, and then that gave us this. So we now need to solve this last equation. Now from mass 101, we told you, okay, thank you very much, Cruising, for that factorization. And we told you that under polynomials, that the degree of a polynomial will tell you the number of values you should get. You see, Chidera now is telling us k is equal to 2. And that's one thing we will give you in exam. And we will put k equal to 2. And I wanted to talk about it. This, your answers that you are giving me now, k equal to 2, is very beautiful, but it's an incomplete truth. Because for this particular equation to have degree 3, that means there should be 3 values for k. And you are giving me only 2. Oh, sorry, only 1. So where is the remaining 2? Okay. All right. Cruising now is getting only 2. Okay. So you still need another one. Meanwhile, cruising, this your bracket is not correct. Oh, I wish I saw where you wrote your name. I told you people to go and change your YouTube, be your WhatsApp YouTube name to be your normal name so that I can be calling you by your name. Which one is cruising now? And I don't even know if I'm pronouncing it well. I'm going up to check where you wrote your name. Cruising, write your name again here. Let me know your name. Or say so. Okay. So, okay. Let me sample the responses I'm getting. Marvelous. That's okay. You're welcome. Okay. I'm seeing 2, 2, 2. And then cruising wrote k minus 4 and k plus 4. Is it k minus 4 or k minus 2? Okay. Is Brian Cruz. Okay, Cruz. All right. Okay, so is it k minus 4 or k minus 2? You know what you have there is difference of 2 squares. Okay, let's get back to it. Okay, we are supposed to have 3 solutions. So how do we get that? First of all, we will do what Cruz did for us, which is to factorize k. If you bring out k here, k is here and k is here. So in the bracket, you will now have k squared minus 4. Close the bracket, and that's equal to 0. Now, what many of you that are getting 2 did is that you divided through by k. And when you divided through by k, you got k squared minus 4 equal to 0. And you took your 4 to the other side, and it gave you positive 4. And you took square to the other side, and it became square root of 4, which is equal to 2. And this is correct, but it is half truth. And that is one of the things that has helped us as teachers, that you are able to bring your student experience, because we did some of these things as students. Now, Chidinma has given us minus 2 and plus 2, which is very beautiful, but that is still incomplete truth. 1k is still missing. And where is that 1k? That's this guy. You are not supposed to eliminate this guy. This guy is supposed to still be here. So watch what we are going to get now. So that's going to give us k. Now, this is the same thing as k squared minus 2 squared equal to 0. Yeah, Cruz, you are supposed to get k equal to 0. Thank you very much. All right, so if we now apply the difference of 2 squares, I'm explaining this for the sake of everybody following, where we have a squared minus b squared is the same thing as a minus b into a plus b. Okay, so that means this is going to be k into, here we now have k minus 2 times k plus 2, and that is equal to 0. So what you actually have here, there are 3 brackets and not just 2. They are 3, and that's how you will get the 3 solutions. So this will be either k is equal to 0, or k minus 2 is equal to 0, or k plus 2 is equal to 0. So there are 3 solutions you will finally get. So therefore, our k is equal to 0, or k is equal to 2, or k is equal to minus 2. So these are the 3 solutions you are supposed to get. And I hope that made sense. Please let me see your response, everybody. Your response to this solution. Cruz, all right, thank you. Yeah. Who again? Okay, Chidinma, did you get the remaining k here? Where are the people that gave me responses? Yeah, Chidera. Who again? Okay, you don't need to delete your response. Yeah, it's part of the learning. You do it and then we correct and then we move on. Okay, so that I will be able to respond to you. I'll be able to respond to you. That response allows me to see your participation in the class. All right, Precious, you came a little bit late today, and that's not good of you. Okay, Blossom, you are welcome too. Okay, beautiful. All right, so I've got a response from Cruz, Chidera, Chidinma, Blossom, and Diamond. All right, so I believe that the rest of us we are following. Yeah, Joy. Okay, so that is how to go about this. So please take notes when you get to exam or whatever. Once you have a polynomial or an equation and the degree is not 1, if the degree is 2, you are expecting 2 solutions. If the degree is 3, you are expecting 3 solutions, and so on and so forth. Okay, so let's go on. Now we go on to example 4. All right, and I will be expecting you to do 4 for me. Okay, so I'll be expecting you to do example 4 for me. Here is it. It says we are also looking for k, or let me change it to h. Find h so that okay, this one now is talking about angle, but I'm going to change it. Find h, okay, let me put it this way, so that the angle between u equal to 1 to 1 and v equal to 1, 0, h is 90 degrees. Okay, all right. You know, for this example, you can just go ahead and use u dot v equal to magnitude of u times magnitude of v cos theta. Okay, meanwhile, I didn't tell you why the dot product will be 0 if your angle is 90. Oh, and nobody asked me. Let's go back there. You know, here we defined that dot product of u and v will be 0 if your angle is 90. I hope you know the reason why. Because dot product is defined as magnitude of u times magnitude of v cos theta. So if my theta is 90, no matter what my u and v are, cos 90 is equal to 0. So the value of my u, the magnitude of u and magnitude of v will be relevant, because once your angle is 90, cos 90 will be 0, and so the whole of this will be giving you 0. I'm sorry that I did not mention this. It's important that you know why that is equal to 0. Okay, so that's why. I hope everybody got that. Please give me a response emoji for that if you got it, and then from there you can go on and now do the exercise here. So here now we are told that we should find h if the angle between these two vectors is equal to 90. So how do you get that? What is the value of your h? I'm waiting. I suppose that Zikora is not in this class. Cruz said he has never heard of orthogonal vectors. You will see a lot of it in our exam. A lot of it. Because it's a beautiful concept. It's a very beautiful concept. Yeah. It's a very beautiful concept. Yeah. Oh, Zeke. And you did not type what I said you should type in the group. Okay? And I've not seen your response before. It's alright. Okay. Okay, Cruz, this is Math 2 linear algebra. this is linear algebra. Okay, is linear algebra. That's linear algebra 1. What type of mass is this? My network is bad. Okay, sorry about that. Okay, so we are beginning to see some responses. All right, Jessica says H is 0. Which other person? Zeke, sorry about your network. You can try to change your position. Okay, yeah. Okay, it's linear algebra. That's the concept. So talking about vectors and algebra of vectors. Okay, so one of the things we discuss is the orthogonality of vectors. Okay, Oni says 0, Favor says 0. All right. Okay, I'm waiting for more responses. Rita, are you here? Zeke, are you here? Okay, Confidence. It says exam. Okay. All right, so let's go on. Okay, so quickly now let me try to explain what I was trying to show you here. You know, there are two ways you can do this, and one of the ways can actually be long. Okay, so because if the angle is 90, I know that u dot v is equal to magnitude of u magnitude of v cos 90. Okay, I can start substituting into this formula, and this method is going to be a long method, meaning that you are going to get your u dot v, get your magnitude of u, and get your magnitude of v, and then substitute, and that's going to take a lot of time. But if you already know that whenever the angle between two vectors is 90, that means the two vectors are perpendicular. That means the two vectors are orthogonal. So you can immediately use the concept that since the angle is 90, that means my u and v are orthogonal. Therefore, their dot product is what? 0. And then you will just use this and solve, instead of disturbing yourself to substitute into this formula. All right, of course, this is one way you can go. Let me keep this as theta. Okay, so you can go ahead and substitute into this formula, or you make use of your understanding that for my angle to be 90, therefore the two vectors are orthogonal. So if we use this approach, who is saying there's confused? Gift, maybe you came a little bit late, but follow me now. So what we are saying is that since the angle between these two vectors is 90, then the both of them are orthogonal. And if they are orthogonal, then their dot product must be equal to 0. Their dot product must be equal to 0. And so I can go ahead and solve now. So how do I get the dot product? We multiply the corresponding values. Okay, so 1 will multiply 1, and that will give me 1 into 1, plus 2 will multiply 0, okay, and then 1 will multiply h, and so everything should be 0. All right, so from here I am going to have 1 plus 0 plus h is equal to 0, and I am seeing 0. Are you sure it's 0? I'm not getting 0 here, so I'm getting 1 plus h is equal to 0. Therefore, h is equal to -1. So how did you people get 0? How did you get 0? I will fight all of you in this class if you give me a wrong answer again. All right? But that's very beautiful. At least I appreciate your participation in that. Yeah, Chidera, Joyce, Chidimma is -1. And in fact, we can check it to know if you are correct. If we put 0 here, if we put your h as 0 like you told us, that's here dot 1 comma 0 0. Are we going to get 0 if we take the dot product? I doubt. Let's check that. 1 times 1 is 1, 2 times 0 is 0, and 1 times 0 is 0. You can see that this is not equal to 0, of course. So that means 1 is not correct. But if you, 0 is not correct. Then if you try -1 like I got here into these two brackets, so the dot product here is 1 0 -1. Here you are going to get -1. sorry, 1 times 1 will be 1, 2 times 0 will be 0, and 1 times minus 1 will be minus 1. And of course, this is going to give you 0. So the answer should be minus 1 and not 0. I hope you understood it now. Please, you can also give some signs to show that it is clear. Okay, and for where is that comment? Yeah, Mildred, I hope it is better now. Gift. Okay, so we've been talking about orthogonal vectors, and we said that two vectors are orthogonal if the angle between them is 90. That's the basic definition. And of course, when the angle is 90, it means that their dot product will be 0. Okay, Rita said she got minus 1. All right, that's correct. Okay, so in that case, I'm going to try to give another example. Let's see what you can do with that. The exercise I gave is number 4. Okay, let me give another one, maybe the 5th one. How do I do that? Which one do I hide now? Okay, let's try this. Okay, so assume that you have v is equal to 1, sorry. Okay, let me put it in bracket. 1, 6, and minus 2. And my u is equal to 2 minus, okay, 2 minus x and 1. Okay, so find x so that u and v will be orthogonal, so that u will be orthogonal to v. You see what I wrote on the board? That's also another way that we can write orthogonal vectors. Even in exam, we can actually put it this way. Okay, so find the value of x so that u will be orthogonal to v. Okay, so I will allow you to also do this one. You have maybe 1 minute to do that. Now, the reason I'm giving this second exercise is so that I'll be sure that you have understood my correction in the previous example. Okay, so everybody quickly, let's do that while I respond to some comments. Okay, so Marvelous says, I thought at the end of our solving, our answer should always be 0. Yes, if the two vectors are orthogonal, their dot product will always be 0. But here now, they have already told you that they are orthogonal. So they now decided to omit a particular vector, a particular value in a vector. And then we are now asking you to get that value so that the two of them will be orthogonal. So what it means is that what value will I put here? And if I multiply these two vectors, if I take their dot product, I will get 0. That's what we are saying. So it is the dot product that's always 0, not the entries of the vectors. The entries of the vectors are not always 0. Some of them can be numbers, but if you take their dot product, you will get 0. So we are now saying, assuming that we decide to hide a particular entry, can you get the entry so that the dot product will still be 0? That's what we are saying. In other words, we are saying for this example now, what will be the value of x so that 1, 6 minus 2 dots 2 minus x and 1 will give you 0. So here you already know that the dot product is 0. You are now looking for the value of x. That's what we are saying. I hope that is well understood. Marvelous. Okay, so we are beginning to receive responses. Excuse me. Okay, so I have responses minus 6, minus 6, minus 6, minus 6. Okay, Ezigwe got 6. Okay, let's see who again blows on minus 6. Rejoice 0. Please, like I said the other day, if your red line is lagging behind, draw it up a little so that you will not be behind us. Rita, I'm thinking your red line is behind because your response is usually coming in late. Okay, so you can drag your red line up so that you can follow us as we are going. Okay, all right, so let's quickly check if that is correct. So even without me solving it, let's do a check. For people that said minus 6, okay, so let's substitute our x as minus 6 and see if the dot product will be 0. Okay, so if we put our x as minus 6 here, minus 6 times minus will be 6. All right, so we now have comma 1. All right, let's go. So this is going to be 1 times 2 is 2, and then plus 6 times 6 is 36. I don't see this giving us 0. And then minus 2 times 1 is minus 2. This is equal to 36, and it's not 0. So you see that you got your answer. The value is 6, but you forgot to remove the minus sign. So it should actually be positive 6 and not minus 6. Okay, let's see it so that you can get what I'm saying. All right, let me drag this up a little bit. Okay, so watch what I am saying here. Now, if you substitute into this, like we said, if you expand this bracket here, see what you're going to have. 1 times 2 will give you 2, then plus, of course, 6 will multiply minus x, and then minus 2 will multiply 1, and that is equal to 0. Okay, so let's come down to this side. What are you then going to have? So that's going to give us 6 times minus x is minus 6x, and then minus 2 times 1 is minus 2, and everything is equal to 0. Okay, so what will happen here is that minus 2 will cancel 2, and that's going to give us minus 6x equal to 0. And so if we divide both sides by minus 6, we are going to get our x as equal to 0. Okay, so and I got some responses as 0, and that is the correct answer. Okay, so of course, if you replace here with 0, you are going to have 1, 6, minus 2 into, dot product. Here you will now have 2. Of course, minus times 0 will still be 0, and then you now have 1. So if you take this dot product, you will definitely get 0 as your answer. Okay, I hope it is clearer now. Got minus 6 minus. I wish I can see a picture of where you got your answer or what you did wrong that made your answer to be minus 6. Yeah, Chisom, what did you do? Where did you do? What happened? Let me bring this up again, maybe into a new page. Okay, we are given that u is we have 1, 6 minus 2, 1, 6 minus 2, and then this is our v, and then of course anyone can be anywhere, it doesn't change anything. I think this one was our v, yes. Okay, so and then the next one was our u, and our u is giving us let me check. Our u is 2 minus x and 1. Okay, 2 minus x and 1. Okay, what is confusing there, Mordecai? Let's see What's the confusion there? For the two of them, remember I said you should find x so that u will be orthogonal to v. And for u to be orthogonal to v, it means that u dot v is 0. Okay? So, and what's the meaning of dot product? So all I need to do is just to substitute here and equate it to 0 and look for my x. So what is the value of u? My u is 2 minus x and 1. And then we have dots. What is my v? 1, 6 and minus 2. Okay? And since x equal to 6. How did you get x equal to 6? How did you get it? Okay, how? Blossom says she has understood now. Okay, check very well. How? If you open these two brackets, 2 will multiply 2 to give us 2. Then minus x will multiply 6. And then 1 will multiply minus 2. And that's equal to 0. So we have gotten 2 here. Minus x times 6, is it not minus 6x? And then 1 times minus 2, is it not minus 2? And everything is 0. Yeah. Yes, of course. You can run the check. Rita, I like that. You can run the check with the options. Yeah, that's one way. Of course, I usually teach students that. You can run check with options. But the issue is that the time you are using to run the check, are you sure it's not going to be are you sure it's not going to waste your time more than the time that you use to solve it? Yeah? It's going to take more time to solve than it will take to run the check, because you will be running the check with all the options, and that will be a little bit more distracting. Like I'm very sure of that. Okay, so all you need to do is just to take your dot. Is dot product now becoming an issue for us? All of you were enjoying dot product in the last class. Why is it a problem now? Take dot product and then make x the subject, or whatever variable that is missing, you make it the subject. That's all. So here now, all my job now is to make x the subject. And of course, these two will cancel minus 2. So I'll have minus 6x equal to 0. Of course, to get my x, I will divide both sides by minus 6x. Of course, this will go, and my x will be equal to 0 over minus 6 is 0. Mordecai, I need to get your response. Is it clearer now? And I am not even moving from this until you people will get one example, all of you. Because I want to be sure that you are with me. Okay? So I'm going to ask another question here, maybe number 6. Because I want to be sure at least a larger percent of all of you should be able to get the correct answer, so that I'll be sure that we are following. Okay, just look at this one. Let me use maybe another symbol for vector. Okay, let's take it that we have vector w is equal to, maybe this time around, let me use y comma say minus 1 comma maybe 2, and then let's say vector z is equal to maybe 3 0 say 1. Okay, then I can ask you to find y that will make w to be orthogonal to z. Okay, so yeah, Chisom says he now understands. I don't know if this Chisom is a woman or a man. I want to say he, and I don't know whether it's he or she. Okay, Chisom, maybe you can help me. All right, so everybody should do this again, so that I want to be very sure. Please do this again and get the y value for me. This thing is 2 here. Rita, you know your board is not always showing very well. What I have here, the last entry in w is 2. Okay, all right, so help me to get the value of y. that will make these two vectors orthogonal. I will give you time again because, okay, yeah, Mordecai, all right. Okay, he, all right, because you are always very active. Okay, so I should know what to refer to you as, because the reason is that people answer Chisom, so I don't know whether your surname is Chisom or which one. All right, so everybody, and please, I want everybody to get this one now so that we can go to the next thing, which is direction, cosines, and angles. All right, quickly. What is the value of y that will make those two vectors to be orthogonal? All right, okay. Okay, I would love the responses to be flowing in fast and now. Self Rejoice has an answer. Okay. Who again? Henry, you are welcome, even though you are coming in too late. Okay. The next one. Chidima, this thing you wrote, is it -2 only or -2 over something? Check it again. If you don't check it well, Chidima, I will punch you because I don't think that this answer is correct. Dimma, please look at it again now. Oh, Dimma, you have always done it well all of the time. Thank you. Rejoice, Onyi, Dimma, Precious, is it positive or negative? Check it. Is it positive or negative? Jessica, yes. Chidera, yes. Blossom, yes. Diamond, yes. Chisom, Chisom, yeah. But Chisom, that your minus can be up. But don't mind me, it's still the same thing. Rita, yeah. Ezigwe favor, is it positive or negative? I think it should be negative. All right. So, thank you, everybody. I think I love the response now. Almost everybody is getting it correctly. So it is -2 over 3. And just like Rita said, just by observing this thing, I already know. All you need to do here, look at what I'm going to do here. Just multiply this one by this one, multiply this one by this one, and equate it to 0. And then make y the subject and move on. So this times this is 3y. This one times this is 0. I'll leave that one. 1 times 2 is 2. And I will equate it to 0. Take 2 to this side. I'll have 3y equal to -2. And finally, divide both sides by 3. You will get -2 over 3. So please, see here. On your exam day, I will be walking around in your hall. I will particularly be in your hall. Some of these questions, you should just look at it and write the answer. Anything short of that, I will knock your head down. Okay, so, and I think everybody has followed up to this point now. Please let me see emojis as signs that we have all gotten it, because now I am progressing to the next thing, which is direction angles and direction cosines. 201 is very beautiful. See, what you should be talking about now is the kind of A you will get, not whether you will get A or not, because if you don't, I'm the one that will record your exams and results. If I see things that I don't like, you will not publish your results till your final year. If I see scores that I don't like. Okay, so let's move on now to the next thing. Okay, yeah, I'm seeing the responses. Yes, if you like, be showing me eyeglass. Chisom, don't worry. If you like, you in particular, many of you in this group, in fact, let me be telling you your name. Chisom, Zeke, Chidima, Ojide, Rita, Rejoice, Jessica, where is she? Blossom, Chidera, Joyce, all of you. If I catch you not giving me good score, not good grade. Your grade is already A, that's good score. I will not publish your result. You'll be looking for it till your final year. Just know that I told you that one. Okay, so let's go on to the next concept. All right, so here now we want to discuss the concept of direction angles and direction cosines. This is another beautiful concept, very, very beautiful. All right, so what does it talk about? Now, let me show you this. If you look at every one of you now, you are in a room, and if you look at the junction of the two walls of your room and the floor, you will discover that it is something like this. Let me try to give a picture to it. It is something like this. As I'm drawing this, you can be looking at the junction I am talking about. The junction of any two walls of your house and then the floor of the house. It is something like this. Maybe this is one side of the wall and this is another side of the wall, and this one now is the floor. Okay, so here is the floor of your house. This is one side of the wall and this is another side. Okay, so that gives you a beautiful three-dimensional space. So we call this three-dimensional. So let here be our X, and let, if you like, be laughing. Yes, Blossom, if you like, be laughing. And let here be our Y. So we are now introducing the Z component. Yes, Sylvia, you too. I did not mention your name. You are part of it too. You will just see your results in your final year. You will be shouting missing scripts. Now me hold the results. If you like, don't get 80. You will not like what I will do. Okay, so now, assuming you were here physically, I would have shown you. If you carry a long stick and put at that junction and draw it, project it out, it is going to look like something like this. Let me use this arrow to still draw it. It is going to look like something of this nature. Okay, but because I'm drawing this on a plane, this thing looks like a line. Maybe it's just looking like it's on this wall. No, it's not on this wall. It is projected out. Okay, so it's going to form an angle with X. We call it alpha. It will form an angle with Y. We call it beta. And it will also form an angle. Let me use blue to draw this one. It will also form an angle with Z. We call that angle gamma. Okay, sorry, confidence for your network. Maybe you can shift a little bit where you are. Okay, so these angles, okay, now this particular line I drew here is a vector. You can call that vector U. Now the angle, I'm now defining the angles between the line of a vector, between the line of a vector and the X, Y, Z axis are what we call the direction angles. Those are what we call the direction angles. NEPA is taking light in my house, so just pray that this battery will stay longer. Okay? Alright? So, don't mind me. So, these angles, alpha, beta, and gamma, are what we call the direction angles. Give me some emojis if you understood what I said now. So, what it means is that alpha, beta, and gamma are what we call the direction angles of vector U. Are the direction angles of vector U. Okay, according to that diagram. Why is there no angle between y and z? You see, you are asking this question means that you did not understand the explanation I gave. The angle is not between x and z or x and y. No, the angle is between you and the three of them. Watch, okay, the light is back, thank you. So the angle is between vector u and the three axes. So alpha is the angle between u and x. Beta is the angle between u and y. While gamma is the angle between u and z. I hope it is better now. So it is not between y and z or y and x or y and z. No, it's not. It is between you and the three of them. It's between you and the three of them. Okay, let me maybe try to give, okay, let me try to give a, what do you call it, another picture to this. Let me try to give another picture. How many of you here you can draw a cuboid? You can draw a cuboid when you were in secondary or primary school. You remember when we used to do something like this? Let me see if I still remember how we used to draw a cuboid. If you draw a cuboid of this nature, you will now insert something like this. Follow me so that I will try to see if I will make this a little bit more understandable. You remember this thing I'm doing now? When you used to draw cuboid in your secondary school. Confidence is raising her hand. Okay, so see what I was trying to explain. This now is my y-axis. Let me use white to draw my x-axis. So this one now is my x-axis. Why this one now? Okay, let me use blue for that. Okay, why this one now is my z-axis. I hope everybody is following me. Okay, so that particular u now projected from this junction. That u projected from this junction, and it came to this one. It came to this place. So it's a projection to, let me try to give that projection. So it's a projection like this. Oh, sorry, I need a straight line. Okay, so it's a projection like this. I needed that line to get to, okay, no, I needed it to get to this point. Okay, all right, so it is actually a projection. So I think you can see the projection better now. So this line, this vector u is not lying down on any of the plane. It's actually a projection inside the box. Okay, so and it formed angle with this one, formed angle with this one, and formed angle with this other one. Okay, so it's a projection. All right, it's not lying down on any of the surface. It's just on its own, projected up. Please give me some thumbs up if you have understood this diagram now. So it is these angles that we are now referring to. So the one that it made with x-axis is called alpha. The one that it made with y-axis is called beta. And the one that it made with the z-axis is called gamma. And that is what we call the direction angles of a vector. Okay, so the question now is, we can give you a vector u and ask you to get the direction angles. How do you do that? Okay, so let's begin. Let my u be the vector. Of course, since we are talking about direction angles in a three-dimensional space, that means your vector u must be three-dimensional. Okay, Rejoice. Okay, so that means my U will be U1, U2, and U3. Okay, so by way of formula, your direction angles are defined like this. Follow me. The first one, angle alpha is equal to your U1, which is the x component, all over the magnitude of U. I've been using one line, so let me use one line. Remember we said that whether it is one line or two lines, that they are the same. Okay, so but let me continue using one line. So what you will use to remember this formula is that alpha is the angle between the x-axis and U. So the formula will be the U component from the x-axis. You know this is usually x, y, z. Okay, so which is U1. And then your beta is the U component from the y-axis, which is U2, all over. The denominator will be the same throughout. And finally, your gamma will be equal to U3, all over the magnitude of U. Okay? Is it beta and plus... Jessica, let me understand your question. Okay? The angle is projecting from the center of y, x, and z. Yes, it's projecting from that point, and then it's going up. All right. So, and then it's forming an then there is an angle formed between the three of them. Okay. So, and those angles are alpha, gamma, and beta. Okay. Jessica, let me get your question. I did not get what you wrote there. So, but this is the formula for calculating these angles. Sorry. Oh, God. Okay, sorry about that. This is not for the angles. This one now is for their cosines. Okay, let me define their cosines before coming here. Okay, sorry about that. This is for their cosines. Okay, so after we have defined, remember I said that what we are learning now is direction angles and direction cosines. So the direction angles of a vector are your alpha, your beta, and your gamma. Okay, now what about the direction cosines? So the second definition is for direction cosines. So your direction cosines is simply the cos of those angles. That's the cosine of those angles. Okay, so the direction cosines is the cosine of alpha, cosine of beta, and the cosine of gamma. So your direction angles are your alpha, beta, and gamma. So my school did not teach us how to draw cuboid. Florence, sorry. Now you go Ajibo school. We go Ajipako, village schools. So in village schools, we were taught how to draw. In fact, we did it as assignment self. They will even ask you to form a cuboid and bring to school. So sorry, you went to Tush school. It's not your fault anyway. Okay, so I have defined two things. Let me outline them down here. The first thing I define is direction angles. So your direction angles are your alpha, your beta, and your gamma. And then the second thing I define is direction cosines. So direction cosines are the cosine of those angles. So you have cos alpha, cos beta, and cos gamma. So, and that is it. Yes, now. Yes, Chidima is laughing. But it's true, Rita. It's true now. If you went to village school, you will draw this thing. There, you will not. In fact, sometimes they will tell you to bring your mother's Maggi. You will carry Maggi and come to school. Or carton of sugar. You know that sugar. Most of you don't know that sugar, that the carton is blue in color. If I ask you to say the name now, you will not know. Maybe, yes, it's possible many of you will not know. But have you heard of this sugar, St. Louis? Have you heard of that sugar, St. Louis? That blue carton? Yes, most times they'll tell us to bring it. Yeah, we bring it, you will tear it, and then form it again. Use sellotape and wrap it. That's the benefit of going to a tobacco school. Okay, Chidera, you know it. You know that sugar is actually produced by an Anambra man, the father of Odumegwu. What am I saying on online? Please, I'm sorry. Let's go back to our class. Okay, so this is direction angles and direction cosines. So let's go back to the concepts now. So here now, you see, I don't even know the spelling of Louis. Confidence spelled it well for us. Abichidera, thank you. Okay, so how do you get the direction angles? You get the direction angles from the direction cosines. So the formula I gave you earlier are the formulas for direction cosines. So let our u be equal to u1, u2, and u3. Okay, all right. So here you are going to have that, let me use green. So our direction cosines, cos alpha, is equal to u1 all over the magnitude of u. Our cos beta is equal to u2 all over magnitude of u. Yes, now is Dangote, you will know. That's your age. You did Chisoma beg. Help Maka, leave me alone. Let me teach my class. Is Dangote? Some of you self don't know Dangote. Is these ones that what do they call it? Condensed ones. All those ones that they used to. Anyway, Dangote own is also condensed. That they used to be powdered. That's the one many of you know. Many of you don't know cube sugar, and that it's not your fault. It's your age. And amazingly, those cube sugars are actually more healthy than those condensed sugar. Yeah, if you go to people that believe all the health stuff, they don't use condensed sugar. I'm not even sure if I've used Dangote sugar. I don't really like the way. Sorry, I'm online. That's somebody's product. Sorry, cut this place. Okay. So let's go on. All right. So your cos gamma will now be u3 all over magnitude of u. So please pay attention. I showed you how to always get this. You don't need to cram the formula. Cos alpha, your alpha is the one that formed between u and x, and u1 is on the x-axis. So it will always help you remember u1 all over magnitude of u. And magnitude of u is the denominator for all of them. Then beta is the angle between y-axis and u. So, and y is the second component. So you should always remember u2 all over magnitude of u. And finally, this one is z. So you should always remember u3 all over magnitude of u. And that is your direction cosines. So what about your direction angles? So already you know how to get angle when you have cosine. So just transfer this cos to the other side. So your angle will just be cos inverse of whatever you get as your direction cosine. So you just take the cos inverse. So my beta will now be cos inverse of u2 all over magnitude of u. And finally my gamma will be cos inverse of u3 all over magnitude of u. All right. So quickly, if this made sense, let's go to some examples. I love the way we are laughing and making fun of this class. That's how every class should be. And that's how I try as much as possible to make my class, so that when you make fun of the class, even in the exam, you can remember where you laugh the way you laugh, and it will help you remember the formula. That's the way it should go. Okay, so let's quickly look at these examples. All right. Okay, so see this one here. Okay, let's do this one example before I introduce. There's something I want to introduce about this direction cosines. Then let's see some examples. Where is that example? I can actually give you any vector at all, and we can get the direction cosines and direction angles of any vector. In fact, let's use any vector at all. Let u be equal to 2i plus 2j minus k. Alright, so find the direction angles. Let's start with the direction cosines because you will need to get it first. Find the direction cosines and the direction angles and the direction angles of u and the direction angles of u. Okay, so that's what we want to do. Okay. You say you fit laugh make you forget and for no, you don't go forget. I'll be going to have marker. Okay, so let's go on. All right, so we have been giving you as 2i plus 2j minus k, and they're asking us to get the value of the direction cosines and the direction angles. So what do? First of all, put your u in the bracket form. U is equal to 2, 2, minus 1. Am I correct? Yes. And then, what's the next thing? For putting it in the bracket form, it means you have already gotten your u1, u2, and u3. Now, what's the next thing? You know that for you to get your direction cosines, you will need the magnitude of u. So you need to get it. Nobody should tell you. So get the magnitude of u. And what's the magnitude of u, everybody? Magnitude of u. I shouldn't be doing some of them at this time. Yes, I'm also giving love emoji for all. In fact, let me give laugh. Okay? So get the magnitude of u for me. For this example, what is the magnitude of u? Alright, 3 is correct. So 2 squared plus 2 squared plus minus 1 squared. That is root 9, which is equal to 3. Beautiful. 3 is correct. Okay, so let's now go on. So for the first one, let me call it A. So I want to get the direction cosines. So I will look for cos alpha. So my cos alpha, which is the first direction cosine, is equal to u1 all over magnitude of u. And that is equal to u1 is 2 all over 3. So that is the answer for the first direction cosine. And what is the other direction cosine? Let me use comma here. Okay, the direction cosine for beta will be equal to what? In fact, everybody should be saying it. For beta will be what? Cos beta will be what? What will be the value for cos beta? Yes, so cos beta is also 2 over 3. And you can also be writing cos gamma. Cos gamma will now be what? Minus 1 all over 3. Therefore, your direction cosines. So direction cosines are equal to 2 over 3, 2 over 3, and minus 1 over 3. And that is your answer. So your direction cosines will always be 3 values, and your direction angles will also always be 3 values. Okay, so I love the way we are, like I told us after the last class, the participation, it always is always very encouraging. I always look up to this class. Seriously, I'm very serious. Okay, so what will now be our direction angles? So alpha will be the cos inverse of 2 over 3. You can use your calculator, press it for me. What did you get? Comma. Your beta will be the same thing, cos inverse of 2 over 3. And finally, your gamma will be the same thing. Sorry, your gamma will now be cos inverse of minus 1 over 3. Okay, what are the values. Be pressing for us. You know, the last time I used calculator. Hey, thank you. That reminds me, I think it was Jessica that reminded us one small mistake we made. Cos inverse of 0.927. I don't know what I was pressing that day. Maybe my mind was not there. Okay, so although some other person also said that it depends on your your approximation, which I also said. Of course, he said something like if you approximated 0.9, you will get 25. But of course, if you use this one, you will get 22 point something. All right, so any of them, that's very beautiful. Okay, so what do we have? We got that gamma is 48.19. Let's make it approximate. So 48 degrees. That means our beta is also 48. Our beta is also 48. Okay. What did we get as our gamma? Our gamma will be what? Our gamma will be what? So, gamma will be what? Gamma will be what? Gamma will be what? 109. 109 degrees. Okay, so that is just that about how to deal with your direction cosines and direction angles. Okay, so if this is understood, please give some thumbs up there. Give some thumbs up. Let me be sure that we followed, because I want to go to another thing. There is a derivation. There is something we discovered about direction angles. And what is that? In fact, about two things, but I'm only going to show us one. Let me call it a remark. So write it as a remark. And what is that remark? The remark is very beautiful. It says that if you, let me see, maybe it will be up to two. Let me just write one. Okay, the first remark says that if you square your direction cosines and add them, the square of the first direction cosine plus the square of the second plus the third, that it will always be equal to 1. It will always be equal to 1. The square of the three direction cosines and the sum of them will always give you 1. Is that true? Let's check. Let's check if that is really true. Okay? Of course, it is true. You are going to see that. Okay? How is it so? Meanwhile, note that this thing here is the same thing as cos alpha all squared. Maybe I should have written it that way. Plus cos beta all squared. That's the meaning of that too. Then plus cos gamma all squared. So we are saying that it is equal to 1. Okay, so let's check if that is true. So what is cos alpha? By formula we said it is u1 all over magnitude of u. So this is all squared. Then plus the second one is u2 all over magnitude of u all squared. Plus the third one is u3 all over magnitude of u all squared. We want to check if this is truly going to give us 1, or if these math people, they are lying. Okay, so if you open up the bracket, the square will come on these two. So you have u1 squared all over magnitude of u squared, plus you have u2 squared all over magnitude of u squared, then plus u3 squared all over magnitude of u squared. Okay, am I supposed to be showing you how we got this? Anyway, let me show you because I've started already. Okay, so if you take LCM of this, you are going to get your LCM is magnitude of u squared, and then all of this will add u1 squared plus u2 squared plus u3 squared. Okay, and if you watch carefully, you will see that your numerator is actually the same thing as the square of the magnitude. Can you confirm that I am correct? If, let me come down here. If your u is equal to u1, u2, and u3, okay, what's the formula for the magnitude? So the magnitude of u will be equal to the square root of u1 squared plus u2 squared plus u3 squared. Abi, is that correct? Yes. Okay, so that means if you square it, the square will cancel the square root and just give you only u1 squared plus u2 squared plus u3 squared. Please give me some emojis if you are following me. Yeah, okay. So that means what I have up here is actually the same thing as the square of the magnitude of u, and the denominator is also the square of the magnitude of u. And so if the two of them cancel out, you will get 1. See here, maths does not lie. Maths is so beautiful that it gives you, assurances for everything we tell you. Okay, so that particular formula is true. And why did I give you that? Because there is an example that you may see, and the only way you can solve it is by using this particular formula. Okay, so let me try to bring in this example. Look at this particular question. Okay, but even before we make use of this particular thing I wrote here, let's see another example on direction cosines. Example 2. Let's see example 2. Okay, it says find the vector. Before I come back to this particular relationship, because I'm going to give you an example that you are going to apply this relationship. In fact, this example I want to give you now, it can even work on it, but we will use the normal formula we know. Okay, yeah. Okay, in fact, I think it is that formula we are going to use. Let's look at it. It says find the vector of length 5 whose direction angles are alpha equal to 45 degrees, comma, beta equal to 120 degrees, comma, and gamma equal to 60 degrees. Okay, so you are given a vector, and the vector is not given. You are told to find the vector. So here we are looking for vector u that has a magnitude of 5. In fact, I've already started solving. Follow me now. So we are looking for a vector u. So let the vector be u. Let the vector be u. Okay? And if it is u, it means that it is going to contain u1, u2, and u3. Okay? So, because it is three-dimensional, since it's talking about direction cosines and direction angles. Okay, so now, right, so if it is u, they told us that the magnitude of u, remember length is the same thing as magnitude, so they said the magnitude of u is equal to 5, and then they now said we should find that u, meaning that all we need to do is to get our u1, our u2, and our u3. Okay, and how are we going to get that? How are we going to get that? How do we get our u1, u2, and u3? remember that there is a formula we wrote up here, how to get your direction cosines. Where is it? Okay, somewhere on the other page. Okay, the formula for direction cosines, we said, look at it here. We said that this is equal to blah 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 and all of that, you know. Okay, so what do we do to be able to get this question that they are asking us? Okay, so see what we are going to do. So we will recall that our cos alpha is equal to u1 all over magnitude of u. So what this means is that, remember, what it means now is that my alpha was given as 45, abi? Okay, so I can put cos 45 is equal to u1 all over the magnitude, and the magnitude was given as 5. Okay, yeah, Rejoice, thank you. Okay, so this is over 1. So I can cross multiply, and my u1 will be equal to 5 times cos 45. And cos 45 is equal to, in fractional form, if you did trigonometry in Maths 101, cos 45 is the same thing as 1 over root 2. Okay, so that is going to give us 5 all over root 2. And we can leave it like that. So we have gotten our u1. So the next thing is to get our u2 and u3. And I want you, if you understood how I got this u1 now, I want you to do u2 and u3 for me. Quickly, everybody. Find u2 and u3. But you should show me that you understood it by touching something, and then you'll be doing it. And then if you did not understand, you can also ask questions so that I can be explaining it while we are also doing it. Okay? But if you understood it, touch something and then start showing it. Help me get u2 and u3, and I'll be doing it also. Quickly. Can our answer be in decimal? Okay, no problem. Go ahead, use decimal. Yeah, you can use decimal. In fact, since you're using decimal, let me also put my own in decimal. That's 5 over root 2. 5 over root 2. That's 3.5. You can approximate to 1 decimal place, everybody. Approximate to 1 decimal place if you want to use decimal. But if you want to use fraction, you can also use fraction. Okay, so this one, my own, is going to be 3.5 approximately in 1 decimal place. Okay, I'm seeing minus 5 over 2 for second one. Minus, is it minus or plus? Some people are writing minus, some are writing plus. Jessica, okay, you have deleted it, thank you. Okay, Chidera, is it my, okay, you are giving me u3. Please be writing the one you are putting u2. Put 2 in front of your u so that I will know you are referring to u2. Put 2 in front of your u. Okay, or you can put the two of them together. Okay, like Jessica just did. Minus 2.5 and minus 2 and positive 2.5. Okay, beautiful, that's amazing. See, I'm really this, let me tell you people the truth, this does not look like the normal geology and geophysics that we know. Okay, this class is very, very different, and I applaud what you guys are doing. the commitment, the learning, the understanding is so beautiful. Yeah, very, 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 very amazing. That's nice. I am happy for this. Okay, so let's do it together for the sake of those that will watch it later. So cos beta is going to be u2 all over magnitude of u. So my cos beta will be cos 120, which is equal to my u2, which is what I'm looking for, all over 5. So u2 will be equal to 5 times cos 120, or you can put it together. If you even press your calculator, it will give you minus 2.5, okay? Because cos 120 is minus half. Then we can go ahead and do our u3. We already know the formula. So u3 will just be 5 cos 60, okay? Which is cos 60 is half, and that will give us positive 2.5. That's beautiful. Thank you everybody. Let me give you some emojis. You have done well. So we have gotten the vector. Therefore our vector u is, you can put it in brackets, 3.5 comma minus 2.5 and then plus 2.5, which you can put in ijk form as 3.5i minus 2.5j plus 2.5k. Now, like somebody asked, can we put it in decimal? Also learn how to leave it in fractions, because that's the most likely form we will leave it if it is exam. So I can leave it like this, which is 5 over root 2. Of course, you should change this thing. You should rationalize it. If you rationalize it, you get 5 root 2 over 2. Then let me not bother you with that. So this will give me 5 over root 2i minus 5 over 2j plus 5 over 2k. We don't like decimal in maths, except if it is necessary. Alright, so and that's your solution. Okay, that's your solution. And because of the performance here, I'm going to give an exercise here, which you will drop in the comment section at the end of the class. But I'll still give an example on that formula I wrote up, and that will be the last thing we will do for today. But let me give an exercise here. So assume that you have a vector whose magnitude, okay, let's go this way. So let v be a vector, or let the magnitude of v be equal to, what should I use now? Okay, let it be equal to 3. Should I use 3? Yes. And let me use what? And let the direction angles of v be given as, be equal to alpha, given as 45. Oh no, I've used 45 before. Alpha should be 30 degrees. Let beta be equal to 90 degrees, and then let gamma be equal to what should I use here? 150 degrees. Okay, so you are find v, find vector v. You are looking for vector v, just like what we just finished doing now. Okay, so you can screenshot this and leave it as exercise while I go to the other concept I told you. So let's see some examples that will involve that particular this thing that I gave us, and then we will use it to summarize this class. Okay, so look at this example. Can I remove here? Okay, I think I can go up. All right, so look at this example. I don't know what number it is. Okay, number 3. Okay, look at example 3 here. Here we are told that find the direction angle Find the direction angle. Okay, no, not that. No, not direction angle. It's still vector. Here we are still asked to find the, okay, let me put it this way. If a vector has direction angles, alpha to be equal to beta to be equal to pi over 4, it says find the third angle. Find the third direction angle, gamma. Okay, so have you followed me to this point? Should I go on? Should I continue? Please respond. Should I continue? This is where the last thing we are doing for today. Should I continue? All right. Okay, so let's go on. So here, okay, beautiful Rita, beautiful Chisom, beautiful Precious. All right, so let's go on. So see what is happening here. We are given that a vector has direction angles. So they told us that they gave only two. They said that alpha is pi over 4. Okay, yeah, okay, thank you everybody. And okay, or let me put comma there. And beta is the same thing as pi. The same thing as alpha, and it is pi over 4. So they are asking us to get gamma. Oh my God. Now, there are two ways you can get this. In fact, there is no two ways. In fact, there is only just one way that you can get this. And the only way you will be able to get this gamma is that formula I gave you earlier. And what is that formula? Yeah, Rejoice, thank you. This is your yes long, sha. Okay, so that formula is that the square of cos alpha plus the square of cos beta plus the square of cos gamma is always equal to 1. So that is the only saving grace you have here. Meanwhile, remember what I told you about pi, that whenever we give you an angle in pi, always change it to normal degrees. You know, pi here is in radians. So if we change it in degrees, we are going to have our pi is 180, and 180 over 4 is 45. So alpha is 45 degrees, and beta is also 45 degrees. Okay, so let's begin substitution. So that means we are going to have that cos 45 all squared plus cos 45 again all squared plus, you don't know gamma, so you write it as gamma, is going to be 1. Okay, so quickly help me get cos 45. Of course, in fraction, cos 45, like I said, is 1 all over root 2. Let's use this one. The fraction or decimal own will give you 0.7071. I know that because, like I keep telling you, I have been using it over and over and again, and so that's why I've been used to it. But instead of using the decimal one, please, let's use the fraction. Okay, so this is going to be, let me use the green marker here. So that is 1 all over root 2 all raised to power 2. Then plus, here will also be 1 all over root 2 all raised to power 2 again. And then here will be the same cos gamma all squared is equal to 0. And we are almost done. What can we do again here? What can we do again? So we are going to now open the bracket So if we open this bracket, what is the square of 1? That is 1. All over, what is the square of root 2? That will give you 2, because square will cancel the square root. And so in the second one, you will also have the same 1 over 2, then plus cos gamma all raised to the power of 2. Thank you, Sylvia, is equal to 1. Okay, so here we will now have half. Let me try to put this here. My board is not scrolling up again and I don't want to go to another page. Okay, so half plus half is the same thing as 1. So you have 1 plus cos gamma all squared is equal to 1. So if we take this one over to this side, you will have cos gamma all squared is equal to 1 minus 1 is equal to 0. You will see how beautiful this thing looks. Very beautiful. So if you take square to the other side, you will have cos gamma. The square root, of course, it will turn the square root. And the square root of 0 is what? 0. Therefore, our gamma is equal to cos inverse of 0. And cos inverse of 0 is equal to 90 degrees. Really, I love this. I love this. So our gamma is 90 degrees. And if you put it in pi form, what is it going to be? If you put it in pi form, what is it going to be? I'm waiting for you. I'm waiting. 180 over 2, that's pi over 2. You are still writing it in degree form, Rita. That's 180 over 2. So you now replace that 180 with pi, which is pi over 2. So thank you, everybody that has followed up to this point. Now, I have a second assignment, which this one you are not going to submit it, but it is going to help you to understand what we have done much better. And then in the next class, I am going to start with it. In fact, you can show me on a paper, maybe on WhatsApp. Whenever I ask you to give me your this thing on WhatsApp, many of you don't. And it's not good, Sha. Okay, exercise 2, pi over 2. Okay, Rejoice, yes. Okay, show that, okay, let me leave this exercise. Let me leave it. Okay, so just do one that I asked you to do. Do it. We will start with this thing I wanted to give you as exercise in our next class. So when we start with it, please remind me in the group that I said that we'll start with this in our next class, and then we will now continue to cross product and then scalar and vector projection, and that will be the end of vector and vector algebra. And you are ready. In fact, with vector and vector algebra, you are ready for our exam. At least 60%. You can get B in Maths 101 and go and as in without bothering yourself. With what we just covered, by the time we get to cross product and finish everything under cross product, you can go and rest if B is your problem. If only B is your problem, you can go and rest. Come back and write your exam and get your B. When I tell you all of this, know that I am very serious. Okay, so this is where we end it for this class. If you have not subscribed to the channel, please kindly do so. If you did not do your attendance and you know you came on time, okay, or I will give grace today whether you did or not. This is Zikora and Evans. I'm not sure Evans is still in this class. Keep the attendance, write it very well, and then submit to me after the class. Like we usually do, if I end the live stream, please come back and then do your appreciation. Say Ezigwe favor. Thank you very much. I can see your thank you. But it will be nice you do it at the end of the class, so that other people that watch the video will see that you really followed the class. And also don't forget to give thumbs up to this video, please. We beg you. All right, have a very nice day. See you tomorrow. All that's if you all agree for tomorrow. Bye.